All right, guys, here we go. So we have our maximum error, which is the amount of error on either side of our estimate. That's what we talked about the last one. So I've introduced the idea of a confidence interval. A confidence interval has this in it. It has a point estimate. The point estimate is your X bar, which is your mean. And then on this side, you're going to subtract your maximum error, and you're going to add your maximum error. And from last time, from the last one, our maximum error is based on the confidence interval or the confidence level. So we've got this sample of 200 students. A sample means we're talking about a bigger population. So let's just assume that this is a sample of EUHS. So this is a sample of EUHS students. Okay? So we sampled EUHS students, and we sampled 200 of them, and they asked them, okay, guys, what was your average homework time each night? And they said, on average, the mean time was 52.5 minutes with a standard deviation of 5.1 minutes. So what we're given is this, guys. We're given this. We're given an X bar of 52.5 minutes. That's our guess. That's our estimate. And we're given a standard deviation of 5.1 minutes. And how many people did we ask? We asked 200 students. So, we've got our pieces together. We want a 99.7% confidence interval, which, if we want a 99.7 level, we go over here and we go, oh, that's 2.571. So our Z value from the last time is 2.576, sorry. And now we can kind of say, okay, these are the things I'm given. This is the equation from last time. X bar plus or minus our critical value times our standard deviation over the square root of n. So now let's just plug them in there. What's our estimate? Our estimate is our mean. Our mean is 52.5 plus or minus critical value for a z-score of 99.7 is 2.576 times our standard deviation, which is 5.1, all over 200, square root of 200 students. Okay, so when we get that piece, we've got, let me find another colored pen, guys. All right, good. So let's just kind of write some pieces in there. So if I'm looking at my confidence interval, I've got my point estimate, which is 52.5. And then over here, I have 52.5 plus 2.576 times 5.1 divided by the square root of 200. And that would be what I've got over here, because this is my error, right? It's my error, and I've got to add my error to this side. And then if I go this way, I'm going to subtract my error. So if I'm going to subtract my error, I'm going to do 52.5 minus 2.576 times 5.1 square root of 200. Okay? So we've got our adding of our error and our subtracting of our error. That's what I did right here. So if we do those, we're going to come up with two numbers. We're going to come up with a number here and a number here. So when we add or subtract those, what we get is 52.5 plus or minus 0.93. So if I do the math for this, I get 0.93. So that gives me two answers. Gives me two answers of 51.57 and 53.43. So I get 51.57 and 54.53. I'll double check on that one. 53.53, sorry, 53. So, we have an interval now. We have an interval from 51.57 to 53.53. So what does that tell us? It tells us something about the entire population, is what it tells us. So if we did a 99 is not 99.7, a 99% confidence interval, our 99% confidence interval would go for 99% confidence interval is from 51.57 minutes to 53.53 minutes. Therefore, we are 99% confident that all EUHS students let's see, spend between 51.57 minutes and 53.53 minutes on homework. Okay? So what we're saying is that we can grab a sample of 200 students and then talk about all the students based on how confident we are. So that's the idea of a confidence interval.